Yeah, hi. So we are over here. I hope you can see the screen over here. Yes, so good afternoon, everyone. It's a very warm welcome to all of you who have joined for this webinar. This webinar is about can India build a globally competitive battery manufacturing ecosystem? And in this webinar, we have esteemed guests from the industry, and we will be discussing with them a lot of questions on the battery manufacturing landscape. So I am Rahul Maity. I am a consultant at JMK Research and Analytics. JMK Research is a clean tech market research and advisory firm, and we work on various sector, renewable energy, electric mobility, energy storage, and green hydrogen. And in this particular webinar, the things that we'll be discussing is India's battery manufacturing landscape and the current implementation challenges, how to build a globally competitive battery value chain through localization, technology advancement, and supply chain development. Apart from that, we'll also check the impact of global battery pricing, market dynamics on India's manufacturing ambitions. Also, the growth opportunities across the battery energy storage systems and other emerging battery applications as well. And also, at the end, we'll look at the industry outlook towards 2030 and the policy interventions to strengthen India's battery manufacturing ecosystem. So I'm very much pleased to welcome our first panelist over here, Mr. Mithil Gandhi. He is a global head business development in the battery energy storage systems at Waaree Group. He's having over 16 years of experience in scaling the business, including the renewable energy and energy storage sector. And he's having expertise in driving business growth and strategic partnerships. Currently, he's leading Waaree's business development initiatives in the BESS sector. Thank you, Mithil, for joining in this webinar as a panelist.
Thank
Then
you,
we
Rahul.
have,
Thank you, JMK.
yeah, thank you, Mithil. Then joining Mithil and us, we have Mr. Akash Kaushik. He's the founder and director of Good Enough Energy. He's an aerospace engineer and having over a decade of experience in leading the lithium-ion battery and energy sector. And currently, he's actually leading Good Enough Energy's mission to develop large-scale battery energy ecosystem, battery energy storage systems, beg my pardon, and strengthen India's domestic energy storage system. So thank you, Akash Kaushik, for being with us in the panel.
Thank you, Rahul.
So before I dive into the topic, and we also hear a lot of insights from both our panelists, I just like to give you an overview of the battery landscape and how it has been going across in the sector. So let's check the India's landscape. So lithium-ion battery demand, how it has been. So India's EV lithium-ion battery demand increased from around 1.2 gigawatt hour in 2020 to close to 17 gigawatt hour in 2025. Now, if you see, there has been a sharp rise after 2021, and that was primarily driven by a rapid growth in electric two-wheelers and three-wheelers, and that has been supported very well by central and state EV policies. And if we check for the projections beyond 2025, the demand is projected to grow at a 45% CAGR to close to 116 gigawatt hour in 2030. So this is about the annual demand of lithium-ion batteries in the electric mobility sector. Now let's see in the BESS sector over here. So if we check for the capacities, how the BESS segment has grown, we'll check the month-wise BESS capacities installments in this particular year. So if you see India's cumulative installed BESS capacity recorded around
Rahul,
1.5
Rahul,
gigawatt.
your slides are not in sync with what you're talking, maybe you'll have to just see what we are seeing
Okay.
is the second slide.
Oh, is it? Thanks for letting me know. I hope you can see the best slide right now. Okay, let me check if
Slide number 2 on the screen.
okay. Let me do one thing. I'll share the screen again. Maybe that works. Can you see my screen? Yeah, I think.
Yes, Rahul, it's visible now.
Okay. Yeah, thanks, Mithil, to let me know about that. I'll then quickly go through this again for everyone who was not able to view these slides. So, as I said, in the electric mobility sector, if we check the demand, uh, from 2020 till 2025, the demand of lithium-ion batteries in EV has seen a rapid growth, and around close to 19 gigawatt hour of demand has been there in 2025. And the sharp rise, as I said, has been because of the electric two-wheelers and three-wheelers market. And coming back to the projections, till 2030, we will see around 116 gigawatt hour of demand, and the growth will be with 45% of CAGR in this. So coming to the BESS, which I was talking initially, the demand for the BESS has been massive till FY 2026. The BESS installed capacity has recorded around 1.5 gigawatt hour. And if we just see the quarter one of FY 2027, it has a cumulative of close to 6.5 gigawatt are commissioned. And this is in just April, May, and June. So that's really massive. And India's cumulative installed BESS capacity is projected to reach approximately 90 gigawatt hour by 2030. And this is also where we get to know that the current India's demand for the current capacity is of the lithium ion cells is around 2 gigawatt hour, and which when you see, you'll get to know that it is not sufficient to meet the rapidly growing demand from the BESS segment. And coming to the last part, this is that how the pricing trends has been at a global level for the lithium-ion battery and cells. So we got to know that the global lithium-ion battery pack prices have fallen sharply from around 700 US dollars per kilowatt hour in 2014 to close to 100 US dollars per kilowatt hour in 2026. But the pace of decline has actually slowed significantly in the recent years. But when you see the lithium-ion cells pricing in the recent quarter, that is from quarter one 2026, the LFP and NMC cells have actually seen a rise uh, from the early January 2026. So this is something that we will be discussing with our panelists as well, that how is this impacting the business. So before we start asking our panels some questions, I'd like to say that you can use the Q&A chat box to drop on your questions, whatever you'd like to ask. And by the end of the time, if we have the time permit, we will definitely ask those questions to our panelists as well. So thanks, Mithil and Akash. It's lovely to have you over here. So I'd like to start with you, Mithil, on this, that you have seen that how the BESS segment actually have been growing. And actually, we also have seen development from the ACC PLI scheme point of view as well, where the government has floated tenders of 10 gigawatt hour in the grid scale energy storage segment as well. And coming to the battery, lithium-ion battery demand, we get to see that actually based on the capacity demand which is there in BESS, we are not making as much cells over here. So what do you think, like, how is this price factor impacting at least the Waaree level at your end? Mithil, you are on mute.
Yeah, thanks, Rahul. So there are multiple things. It's not just the price factor that is, resulting into the what you just mentioned. So it's a combination of policy, which right from push for local manufacturing to the duty structure to the loopholes in the policies like mover, and then comes the support for local demand, local manufacturers to at least get started and come to a level where they can compete with the other suppliers to the Indian market outside of India. So it's not just price that is the determining factor. Having said that, we there are a lot of conversation that are happening at different level to resolve these ambiguities at policy level, to provide a positive push for ALBM and to support the local manufacturers and to create the entire ecosystem, not just the best manufacturing, but also cell and upstream, and not just for stationary storage, but also for the other industries like EV and telecom, so that we can be Atmanirbhar self-sufficient when it comes to energy generation, which is happening in solar and storage, which is likely to happen in this.
Yeah. So I had in continuation to this one more question. Like Vari has been actively expanding in the best segment, and from your experience, what do you think? Like how much progress has been actually made in India from the announcements to commercial manufacturing point of view? Because we do get to hear a lot of announcements being made uh, in the best segment, but actually the commencements are sometimes a different scenario. So maybe could you let us know what is happening at Vari in this, and maybe you can let us know the actual scenario on that.
So, for as far as Waaree is concerned, I mean, we are a listed entity and we are very careful of what we speak in media and what announcement we make. So, we probably are what I call a say-do ratio. So, we are probably there 100%. But as far as industry is concerned, I think it's not the intent to just make announcement and stay back. I mean, the overall ecosystem is getting developed. Sometimes we become impatient that someone makes an announcement, they should roll out things, but it's a product. It's a solution, not a product. And because there is no vibrant ecosystem of the components, the trained people, design people, and so on. So it will take time for industry to, get to a higher say-to ratio and deliver what they commit. But in Vari's context, I mean, we can't go that route.
Thank you, thank you. That's really good to know. So Akash, I have a question for you with this, and coming to your point where uh, good enough energy is also growing really good in the best segment. So according to you, what are the biggest bottlenecks you see today in scaling the battery manufacturing in India?
Yeah, Rahul, as I'll second Mr. Gandhi, like several ecosystem labs and loops are which are stopping like best manufacturing or battery manufacturing in India as whole. holistically this ambiguity into the custom duty, mover scheme, and other aspect like how ALBM is being drafted and implemented will create some sort of hurdles. But when it comes to the approach, what India has been following is absolutely spectacular. Coming to the point, like how we should proceed, we have our personal reservations as good enough. Like we believe there are multiple engineerings involved in battery energy storage system or battery itself. Electrochemistry is one of those. Apart from that, mechanics, electronics, thermal, cyber security, networking and communication, IT, and many more are included, including thermal management, which is absolutely the core of battery life is important. What we feel electrochemistry in last 2 years has developed very fast in China. To when it comes to the materials as like sodium ion and zinc air, which are alternative to lithium, have also evolved very fast. But LFP in itself in last 2 years have went from 2,000 cycles to 10,000 or 12,000 whatsoever. This transition is very fast. Putting our legs in transition as country India will may put us in trouble. Yeah. So electrochemistry development with the materials which we already have or developing with sodium ion or something will make sense as an advanced chemistry ACC and the PLI for ACC. But putting our extra efforts on lithium ion or lithium iron phosphate again is not something very judicious to talk about. It's something as an analogy. 5 years back, there were so many iterations into the cell phones. Like every second month, we had a new design. Same is happening with the batteries today, the electrochemistry itself. But today, we don't see much changes in our cell phones. Only camera changes. Rest everything remains same almost. So the technology in cell phones have saturated. So there will be a time when electrochemistry will be saturated. But as of country, as India, there is much more into the value chain apart from electrochemistry when it comes to battery. So we must focus on the other parts as of now. And when there is a saturation, we may start working on electrochemistry also.
That's quite nice point, Akash. Mithil, on this, I'd like to ask, like, as Akash pointed, electrochemistry as one of the bottleneck in this. Do you find is there anything apart from the technology, like maybe the raw materials or financing, or any other thing that you feel that needs to be addressed first in this case?
No, I don't think financing as such is a problem because a lot of these solutions are deployed at scale globally. Today, the entire financial world is very much integrated, and you have a lot of international lenders and equity investors in India who come with more experience than even some of the Indian developers. So financing the project, managing the risk are not a problem when you talk about utility scale projects. Technology risk will remain for foreseeable future. I mean, when you are looking at investment into cell, the biggest question that you ask yourself is which chemistry I should commit to, which technology I should commit to. I mean, that is the biggest risk, which, and there is no way, I mean, it is beyond your control sphere to, address this risk. So, uh, uh, it will get answered by what happens in China, what happens in Europe, how demand changes in US and India, because these are the four big markets who's going to determine what is going to be the technology of tomorrow. And it is not just cost that is at play. There is geopolitics at play because raw material access for sodium ion is going to be very different than lithium ion. So people are looking at sodium ion not because it is, apart from technology advantage, it also has geopolitical advantage as well. So there are a lot of variables at play to make it even more complicated than a single decision.
Right. So, as you pointed about the China factor, So in continuation to that, actually, I had a question. Like we know that China's leadership actually extends beyond cell manufacturing, like it's into materials, equipment, and integrated supply chains as well. So, which parts of the battery value chain you think should India prioritize over the next 5 years?
So you can look at what has happened in solar and probably take that as a stencil because that has given a favorable result to the industry, government, as well as the developers. So you start from the downstream where low capex, high revenue, relatively more of a design than technology kind of play is there. So which is here the integration business, pack and BESS, and so pack and solutions, depending on which industry you're talking about. Then you go up step, one step upwards upstream with cell, and then probably in the raw materials, and that something has to be done at G2G level to secure the mining part of it, because there is a vibrant ecosystem up to AMCAM level getting developed in India and outside of China as well. But when it comes to the raw materials or sourcing for AMCAM also, that is more of a G2G play and has to be managed, at that level, taking industry along.
Akash, would you like to add into this?
Yeah. So see, India has a lot of advantage over China. So I don't say like we have to just beat China, but yeah, we have something which we can work in alongside of China. The labor cost in China is definitely cheaper than anything. Like you see, the bare minimum wages in China is 6,000 RMB, which turns to somewhere like 90,000 per month. Even after the recent strike of labor, India can have easily 20,000 labor rupees per month labor. So it's a stark difference of 5 times. The electricity cost in China is extensively high. It's 1.2 RMB to 1.6 RMB from peak to off peak. That sums around to somewhere like 14 rupees to 21 rupees. In India, for industries, we have discounted electricity at a rate of 5 rupees. IT is absolutely not comparable at all. We can have any engineer for 50, 60,000 to develop a code for you. Whereas in China, you have to pay somewhere like 3 to 4 lakh rupees a month. After sales service of BESS across the world, what India can provide, no one else can. Again, the cost of resources is very low here. If you call upon an engineer from China, they will definitely charge you $500 a day. That could be a monthly wage for one of our engineers. So there is much more in there where we stand very different and very competitive to China. And on top of that, the mother of all deal, this FTA, which we recently had signed with multiple countries, gives us edge of 14% extra. So yeah, India is transitioning towards something as a China plus one alternative, and people are loving it. We will rise.
That's a good point, actually. Mithil, I wanted to speak on the localization part as we all are discussing that how India can be globally competitive when we are comparing with the country like China. So, how important is localization, like not just of cells, but also if we check in other components like the BMS and the recycling part as well, like is like how India will be competitive in this part in the localization.
So all the factors that Mr. Kaushik mentioned would also get uh, played in the localization journey as far as cost is concerned. Uh, Localization journey, as we have seen with other industries, is kind of chicken and egg. Demand and supply, demand and localization both goes hand in hand. Till you show some demand, local investment would not happen, and till local investment doesn't happen, the other side of the aisle would continuously argue that there might be some uncertainty in the supply chain, and let's not even go localization way. So at some point, we will have to government will have to step in and create a continuous long-term demand and a very clear path to indigenization of the components. Uh, and and that's when the more focused and dedicated investment would happen at component level, be it EMS or other electrical and cooling and structural components. Uh, so I don't think there is dearth of. So today in EV space, all the email, let's say pack is almost 100% indigenized. I don't see why that cannot be replicated in stationary storage. It's just matter of showing long-term demand to the active participants in the ecosystem.
Nice. So maybe Akash, could you tell us how is the localization scenario at Good Enough Energy? To what extent have we localized at the best?
So as of today, we are somewhere like 27 to 28% localized. And we are targeting to make it 35 by end of this financial year only. You know what we believe, if you really want to write your own book, you have to read someone else's book first. Yeah. Then you understand like what is worth about and what people like and what is actually to be done. So we have a philosophy of choose the best and make it better. So this is something what China has done with Japan. So they chose the best and made it better for all the world. That's what we are trying to do also. Like we are choosing the best from China and try to make it better than them here in India. And that's where localization coming into picture. When it comes to anything apart from electrochemistry cells, we as country are capable of doing. Be it any sheet metal work, be it the cooling plate, be it the container, and be it anything into the sheet metal. And when it comes to the BMS, absolutely doable. But the data set for SOC and SOH algorithms, what China would have collected is far ahead than what we have as of now. So definitely we need to collect much more data to just make our BMS systems and electronic system more agnostic. PCS is something which we are already developing. So that will be all with us. Chiller is already developed. It's made in India as of today, whatever we use. Rest wires and cables, absolutely all are made in India. The IT part, everything has been written here at Good Enough, not even at some third party agency of IT. So yeah, we are somewhere like 27 to 28% in our value chain as of today, and will be somewhere like 30 to 35% by end of this financial year.
So if we look at the ACC PLI scheme, right, in the first two phases of that scheme, where around 40 gigawatt hour was allotted to the companies who were mainly working in the cell manufacturing part. And we all know that how the current status is. There were big commitments, but in reality, we are not able to see much progress in that. So now in the remaining 10 gigawatt hour, which is going to be for the grid scale energy storage system, what do you think, like how it can uh, take the India's battery manufacturing landscape ahead?
Yeah, so what they have done is fantabulous. When I say they, I mean Ola only, though their performance and share market would have been very indicative. But yeah, to the core of understanding what I have seen, yeah, they have done fantabulous job, and that's how you grow. But the strategy what they took time back today may be obsolete. It's not working well. The NMC chemistry is something which people are not very much relying over, and the new development in LFP and sodium ion has been superseding it. So probably they have to start again from the zero. And all other both Reliance and others have been trying to have TT from multiple companies. By God grace, they will succeed or not, but they will definitely develop something of their own basis. Feradion, the company they would have acquired time back. That is all about sodium ion thing. And though India don't have lithium, and so does China also don't have much. they have some 30-40% of lepidolite. All they have to process there is very expensive, the lepidolite. And the spodumene and other brine thing which they have to import from Zimbabwe, Australia, or maybe the triangle of lithium, Bolivia, Argentina, and Chile. So they are also relying over the import of raw ores from cross border, but they have capability to make precursors, refining it. We still have to develop it. So as of India or maybe the ACCPLI, the more focus should be towards the precursor development and cathode development, anode development. Graphite, we have enough of it, and to the materials and resources which we have in abundance as like sodium and others. We should be technology agnostic, at least electrochemistry agnostic. If it changes tomorrow, we must not be like, okay, now we can't do much as like Ola, I can see they have to pivot it again, start from zero. If not today, maybe after 2 years.
Mithil, would you like to add something into this, like the ACCPLI scheme 10 gigawatt that has been allotted for the energy storage segment?
Yeah, so what uh, previous phase did not happen for multiple reasons, but now there is a clear demand. Uh, Maybe the overall ecosystem and industry is more mature. There is more financing also available for such large capex. Uh, it should take off. And what we are hearing at multiple levels is there are more interested parties than there were last time. There are more serious players and people with large balance sheets also, when because it's again going to be very high in capex. So we hopefully the time is right now for this current phase of PLI to pick up and get into execution, and hopefully the learnings of past will be replicated so that the PLI can be leveraged, not just the capital commitment that happens, and people get benefited out of the PLI, and the whole industry can be developed around this, and we come to a cost curve which can compete with our neighboring countries.
So as you talked about the cost curve part, I just wanted to highlight back to that point what we discussed in the presentation as well, the pricing factor. I know, Mathil, you did say about that it doesn't impact much, but still it's something like even the market wants to know that we have been seeing the lithium ions price have been increasing in since the beginning of 2026. So is it like it's impacting the economics of the BESS projects, or do you see that there has been any drop in the customer demand or any impact in the project timelines as well?
Yeah, definitely. So it's all whatever you mentioned is all happening. A lot of projects that were bidded at very competitive pricing are facing serious viability issues. Uh, with the current pricing, they are not even able to close their, financial closures are not happening. Uh, the lot of the other merchant and CNI business cases that were making sense at the lower price, uh, because the kind of arbitrage that we were seeing then are not making sense because my capex has gone up by 20-25%. So IRR has fallen below my threshold. So that's not happening. So and people are finding loopholes and reasons to delay the project commitment for the already won projects. So all this is happening. Uh, we will have to wait and watch what happens with the pricing, because again, the way supply chain is structured, it is not just demand supply game. It is also capacity available, policy, intention of the geopolitics gets involved as well. So we'll have to wait and watch what happens. But definitely pricing uh, are slowing down the overall progress. But the point I started with was on the pricing differential getting played out. That can be, I mean, that should be the first step to, provide a equal playing field for Indian manufacturers and Chinese OEMs. And then probably we should look at how do we as an industry work towards bringing down the price, controlling the supply chain so that you don't have dependencies and more deployment can happen in India.
Nice. Akash, would you like to say like what challenges you were facing at Good Enough Energy because of this pricing factor since Q1 of 2026?
Yeah, actually, see, we started time back. It was in 2023 when first standalone tender came into picture for UPPC. There were 5 sites of 40 megawatt. So 3 were fetched by JSW ECME Avada and other 2 were with us. We got that bid for somewhere like 10 lakh rupees per megawatt hour per month. So today it seems like I think like a cake thing. But subsequently, the very next tender was from GUVNL, and that was won by Genso. That was for 4,41,000 the very next month. So now, to the amazement or not to the amazement, this was just signed that our tender will be cancelled because there was a stark difference. We asked them like why and how you were able to do this. So the response from them was like we have done some financial engineering. We were glad. Okay, probably we don't know what is financial engineering, but now everyone knows what was financial engineering. So following them, everyone has bidded some speculative pricing. Yeah. So it was something speculative altogether. It was not calculated at all. And those speculations didn't came good to everyone. And the viability was not there at that time also. And it's still not today because the speculations may go wrong and they did. So we conceptualized our factory and system for 20% of India's requirement. That time it was indicated 32 gigawatt as the national requirement. So our factory is 7 giga. So this was 20% almost. And we were happy that we will be catering this of requirement. It's almost 3 years today. We haven't done even a single utility project. It's okay because we believe we don't want to be in a state where we cannot sustain. And we don't want to do something where the vision of making good enough as a global brand go into vain. So today we just focus on C&I, the commercial and industrial segment, and we are happy while doing it. To the question you asked for the challenge, no, there is no challenge as such because we are not focusing on utility.
And do you see the prices to increase even further in the next quarter?
See, I says for lithium-ion batteries more like a commodity today. They'll keep on going up and down. So that's not something we can say like it'll go up or down. But there are always some calculation, not speculations. Yeah, we know how China process lithium. We know it. We know how much of percentage they have with them and how much they import. And if they mine lepidolite, it's a hard ore. You need a lot of energy to drill it and excavate it. And when you drill and excavate, this energy cost and your cost of final ore can't be lower than that energy cost. If I assume ore is for free. Yeah. So the number says itself that yeah, the threshold is somewhere like 70,000 RMB per ton for the lepidolite. If any time it goes lesser than 70,000 RMB per ton, it will be for maybe 2 months or more or less. It can't be more than 2 months or 3 months because that's the general contract miners have with the customers for 3 months. After that, it has to go up again. So the thresholds are already there. This will keep on going up and down. But those who know calculation, they understand what's the threshold.
So let's now look at the demand side of the industry. So Mithil, coming back to you, how do you see the BESS market evolving over the next 5 years? And what role will it play in driving domestic battery manufacturing?
So market demand is going to be phenomenal with more and more use cases being explored, not just the utility, best to support the grid, but also new policies are supporting behind the meter CNI, where Mr. Kaushik's company is also focusing, and then you have ancillary services revenues coming in at some point to make these business cases more and more viable. So demand is the if you look at overall energy demand and the best demand is function of per capita energy consumption going up, as well as solar and other renewable sources which are not available 24/7 getting added to the overall generation portfolio. So that's going to keep rising, and then multiple revenue stream will give rise to further demand. The cell manufacturing and ecosystem development would largely, at least, will require some initial support from the policy front. Without that getting, I mean, we can obviously have initial starters from industry, but to scale it to a level where you compete globally at the cost curve and quality level would be difficult to get without initial policy support. And you see, a similar thing. You look at electronic manufacturing. You take any other strategic industry where government focus provided some initial support from be it incentives or some sort of non-tariff barrier, and then that industry has flourished, and then you are able to compete globally. So I think similar path should be taken here as well to create local manufacturing ecosystem at not just cell or best level, but overall as a industry level, and not just for stationary application, but also for EV and telecom. And we should look at this as a one whole piece. And now that is also happening. MHIS kind of trying has become a nodal agency for all the storage part. So that as we talk, it's happening, but we just have to kind of be more active around pursuing this ambition and push policy matters forward as soon as possible to not lose time.
Right. So, Akash, coming back to you, beyond BESS, where do you see the next major opportunities for battery demand in India?
See, it's impressive to see that when we started with thought of in C&I, DG mitigation and optimization is the first thing where BESS will be used. And when we tried all our efforts in a year time, we learned that's the mere section of requirement of BESS. More than DG mitigation, we have other 22 factors and applications where BESS is directly being applied and used and giving the paybacks in very fast period of time. When it comes to industry and sectors, definitely data centers and how to say grid utility and DERs, distributed energy system and resources for arbitrage. These are something which we can see with bare eyes. But there are more things where we see as like process industries where even a smallest fraction of time can create a lot of process loss. BESS plays a vital role. It's something which is a solution to the problems of UPS and diesel generator. So it's a new category altogether and will be adapted and accepted slowly and gradually at multiple places. So the application remains indefinite. Every time in a month or two, we always get to know some different sort of application which we have never thought of. So I cannot say like a BESS is something which is limited to some application. There are infinite possibilities to just apply it. It's a storage device which solves multiple problems of time shifting, energy shifting, and optimizing it for backup solution.
That's really nice to know, Akash. Thank you for your insights. Mithil, if I talk about the policy part, right? So, what policy interventions do you believe will have the greatest impact in accelerating India's battery manufacturing ambitions over the coming years?
So it should start with, first of all, clarifying some of the loopholes in the policy level, like say movers or the BCD where 10%, 20%, there has been some debate and then it was settled, but then what is favorable to the industry, and then obvious next step would be to align all the stakeholders to get to the ALBM, where we start with push for localization from the solution and then go upstream from there with more and more increasing the local content at the solution level to cell manufacturing and then incentivizing the upstream as well. So combination of closing the loopholes, tweaking the existing BCD tariff structures to creating some push for ALBM, and from there to PLI, or some of these running in parallel, because the PLI, where the PLI is deployed, my capex cycle is going to be say 2 years at least, right? As compared to ALBM would take little lesser than that, and other tweaks can happen immediately. So not that we have to go sequentially about it, but also to go parallelly about it, so that in next 3 to 5 years you see a very vibrant ecosystem in India. And India is not just solving for its own demand, but also at par with other countries when it comes to export into developed markets.
Akash, would you like to add into this regarding the policy interventions that you feel can have a greatest impact?
Of course, like there are multiple representations from different agencies like ISA, NETRA, and maybe from JMK Research also, which have been presented to Ministry of Power, Energy, and other. This misinterpretation of mover scheme and the custom duty thing, which is 5, 11, or 22, which is creating all the trouble. And more than that, it's all about the ecosystem, how recently China has one bid for cell procurement of 1 GWh cell. There were 5 bidders. There were 3 companies which were top tier, 2 were tier 2. I won't name the tier 2 ones, but the price was somewhere like $48 for 314 Ah from them, and $56 from EVE. And EVE was the highest one, and the tender was awarded to highest one. So we have to understand like how the system functions. Why China is not that stupid that it will award the tender to highest one. Yeah. So we need to understand that how tenders are awarded in India. The whole tender process need to be revised. This is a technology-driven product. It's not something like lentils or some vegetable that this may go for reverse auction straight away. So this, when we don't know the pre-qualification criteria for the participant and we don't know how much they know about the individual product of supply. This is new to the world, not only to India. Battery energy storage systems, we have seen 1 kilowatt-hour battery exploding. Imagine 5 megawatt-hour or 100 megawatt-hour exploding. So it's a national asset. This should be procured very meticulously and diligently. So the demand is not more about the subsidies or grant or thing. It's about the process of tenders that should be revised.
So, Akash, if I go back to the chemistry part that we were discussing earlier, what do you think can be the impact of sodium-ion battery storage technology on the overall BESS industry? This is something we have been asked in the Q&A also by the audience. So, what do you think on this?
It's not about the sodium ion only. There are multiple alternatives to lithium ion, but we have to understand the number of grants and research being done on lithium iron phosphate are much higher than sodium ion and zinc or any other alternative. So solid state battery is coming into picture. So if we have a lithium iron phosphate with solid state only, it overrules many of the factors sodium ion has. So it's a race of lithium iron phosphate and sodium ion. We cannot see or say that sodium ion will supersede lithium iron phosphate. This may happen and may not. It all depends on the outcomes of the research being done. So I'm supportive of sodium ion only because I am from India and we don't have lithium resources. But if I have to talk globally, I don't see lithium iron phosphate going anywhere in coming 10 or 20 years.
Mithil, I wanted to ask one question that was regarding the localization. And this is again something aligning with someone who have asked in the Q&A. And that's India has the capability for making the end plate cover and also other cooling systems, but the parts are still imported from China. So what do you have on this? Because that's the reason I was asking about the localization, because there are various components that India is capable to do it, but we still see that it is being imported from China.
Not really. So a lot of at design level, people are shifting, but obviously there might be some uh, quality consistency issues, some cost differential. So that only can be covered once you have demand for localized product. So best manufacturer struggles because there is no demand for best integration that happens in India. Once that happens, then you increase the localization content. We then have to invest or work with the local suppliers. So not that there's something available, everything at par, and still we someone likes to import from China. I mean, no one. I mean, it's not that easy to deal with the neighboring countries where you have issues. There are issues related to visas also for both parties. Lot of challenges. So no one prefers to work if you get everything at par or being pushed to do it. So that would be my, I mean, using my words very carefully, but this is what my response would be.
Akash, would you like to add on this?
See, end plate is not a big game. Yes, definitely anyone can have it here. It's just a simple extrusion thing. But when it comes to liquid cooling plate, it's not an ordinary sheet metal work. This has the responsibility to control the gradients in the battery while maintaining the auxiliary cost. So when you have, am I stuck or you are stuck? I think he is stuck.
Sorry, I didn't get you, Akash.
Yeah, Rahul, you are there?
Yeah, and there.
Anyway. Yeah, so cooling plate is a bit of a technology content. It's not simple sheet metal work. It is something which balances the auxiliary cost and the gradient together. If you maintain much of a gradient level optimization, then your auxiliary cost or auxiliary electricity consumption increase, and so does your overall project cost. So that's where good enough master patent lies into the thermal management. So we have our own cooling plate, but if you say that we can import it or make it, yeah, we can make it definitely as India. We as good enough are doing it, but having it for the right purpose of maintaining the gradient and optimizing auxiliary cost is technology content.
Great. So, Mithil and Akash, I have one last question for both of you. And this is something where I just want you to complete the sentence. Whatever you feel, you can answer on that. So it's like, Mithil, starting from you, if India's battery manufacturing ecosystem will succeed if. So, what
If
do you think?
if there is a initial support to kickstart the ecosystem play. Sorry for long statement, but yeah, I mean, putting a word there is not possible.
And Akash, like India's battery manufacturing ecosystem will succeed
If we start valuing the product, the value it delivers. Uh, I mean, like we cannot be like comparing every individual in China, picking up the best of China and then comparing it to the worst of India, or doing the otherwise, picking the worst of China and comparing to the best of India. If we keep on doing this, we will never succeed. we should give enough of breathing space to the developers and technology development companies.
Thank you. Thank you, Akash. We do have one question that we recently got from the audience. Maybe Akash would like to take it. So it's like, do we have research institutes like IITs, for example, funded for manufacturing line design? Or do we see them working on product level only? When do we see India getting out of China's dependency in this race? So there's something like everyone wants to know, when is India going to be independent of China? And what do you think, how important it is?
It is important, and we all should work together. But when it comes to, as I said it earlier, if you really want to write your own book, you have to read someone else's book first. So importing some initial level of technology and production line from China is like reading someone else's book. So today we can see there are multiple line manufacturers or production line manufacturing companies which are able to do it, but they first need to see something functioning here in India. They would have witnessed us or some other people who would have imported it from China, and now they are able to do it. So they have read the others' book. So it's absolutely doable, and we all should do it, and we all are doing it. But we shouldn't say like why we did import it the first one at first time.
And Mithil will take one last question from the audience, and I think you can take this. How large do you expect the Indian CNI BESS market to become over the next few years?
Very, very large. Putting a number there, I think ISA has done a good job releasing a report. I don't think I am the right person. Rahul and your team would be right person to put a number there. But it's going to be a very large market. But it is still, again, policy dependent at state level, where things, for example, Maharashtra released something, but then it is still not come out with 100% conviction. And hopefully all the states will follow the lead, and that will create a very, very vibrant and large market. It's a decadal journey. I think we sometimes get too much focused on what is happening today and this month and this year. The way things have, if you look at last one decade, 10 years, 2015, where solar was, I think that's where battery is today. And it's going to be a decadal journey to get to a very mature level, self-sufficiency, exports, uh, achieving global cost benchmark as well as quality benchmarks. Uh, and obviously there will be support needed from center and state government for different uh, parts. So maybe you asked a different question, but I thought I'll just take this opportunity to summarize as well.
Thank you. Thank you. So thank you, Mithil and Akash, for sharing your valuable insights and experience. It has been really nice discussing with you. And it has been actually engaging discussion, to be very honest, along the India's battery manufacturing landscape and the localization part, and also talking about the electrochemistry part that you said, and talking about the pricing factor as well, and how the policy can also play a role in the energy storage segment. I'd also like to thank everyone who joined us today, and we hope you found today's discussion informative. You can check our reports at the jmkresearch.com regarding battery ecosystem and manufacturing landscape. And on behalf of JMK Research Analytics, thank you once again for your participation. Thank you, Mithil. Thank you, Akash.
Thank you. Have a nice
Thank you so
evening.
much.
Thank you.